In this tutorial we will discuss Rutherford's model of atoms. Let's start with introduction. After failed of J. Thompson's plum pudding model to explain the atomic structure of elements, a British physicist Ernest Rutherford proposed a model of the atomic structure known as Rutherford's model of atoms. In Rutherford's experiment, he bombarded high-energy streams of alpha particles on a thin gold foil of 100 nanometers thickness. The streams of alpha particles were directed from a radioactive source. He conducted the experiment to study the deflection produced in the trajectory of alpha particles after interaction with the thin sheet of gold. To study the deflection, he placed a screen made up of zinc sulfide around the gold foil. The observations made by Rutherford contradicted the plum pudding model given by J. Thomson. Experimental observation of Rutherford's model of atoms is shown in the diagram. In this experiment, the alpha particle's radium source is placed inside the lead block, the beam of alpha particles is narrowed by applying a lead slit in the root, and highly energized alpha particles are permitted to strike on the thin gold foil equipped with a circular fluorescent zinc sulfide screen as shown in the figure. When alpha particles collide with the sulfide screen, they emit light flashes. Most of the alpha particles, around 99%, directly pass through gold foil without any deviation. Only few alpha particles deviated through small angle, and only few alpha particles are deflected with angle greater than 90 degrees or rebounded in back direction as shown in the figure. Since the majority of the alpha particles traveled straight through gold foil with no deviation, this demonstrates that the atom has a considerable amount of empty space. Few alpha particles deviate at a modest angle, implying that they must approach a hefty positively charged body within the atom. This demonstrates that the nucleus, which is a dense positively charged mass, is located in the core of the atom. Since only a few alpha particles deflected with an angle more than 90 degrees or renounced, this indicates that alpha particles have a direct interaction with a hefty positively charged nucleus in a relatively restricted location. Experimental details of Rutherford's model of atoms. In this experiment, a piece of radioactive substance is placed in a lead block which is constructed in such a way with silts that only a narrow beam of alpha particles could escape. The beam then passes through thin gold foil. In order to detect the alpha particles after scattering, a movable circular screen coated with zinc sulfide is placed around the gold foil. When alpha particles strike the zinc sulfide screen, they produce flashes of light or scintillation which can be detected by examining different portions of the screen. It was possible to determine the proportions of the alpha particles which got deflected through various angles. Observations of Rutherford's alpha particle scattering experiment. The following observations were made from this experiment. Most of the alpha particles passed through gold foil without deflection. Some of alpha particles were deflected through small angles. Very few alpha particles were deflected through angles more than 90 degrees or even bounced back, suffering a deflection of 180 degrees. Conclusions of Rutherford's alpha particle scattering experiment. The following conclusions were made from this experiment. Since most of the alpha particles pass through the gold foil undeflected, it means that there must be a very large empty space within the atom. In other words, atom is mostly empty. Alpha particles are positively charged and have considerable mass. They can be deflected only if they come close to some heavy positively charged mass due to force of repulsion. Since some of the alpha particles are deflected to certain angles, so there is heavy concentrated positively charged mass present in the atom occupying a very small space within, as only a few alpha particles suffered large deflections. The strong deflection or even bouncing back of alpha particles from the gold foil must be due to the close encounter of alpha particles with the massive positively charged mass present in the center on atom. Postulates of Rutherford's model of atoms. The following assumptions were made from this experiment. The entire mass and the positive charge is concentrated in a very small region at the center in an atom called nucleus. It was observed that the radius of the nucleus is of the order of 10 to the power minus 13 cm, whereas the radius of the atom is of the order of 10 to the power minus 8 cm, means the size of the nucleus is extremely small as compared to the size of the atom. The magnitude of the positive charge on the nucleus is different for different atoms. The nucleus is surrounded by negatively charged electrons which balance the positive charge on the nucleus. The electrons are not stationary but are revolving around the nucleus at very high speed like planet revolving around the Sun. The electrons are also called planetary electrons. Most of the space in an atom between the nucleus and the revolving electrons is empty. Limitations of Rutherford's model of atoms. The main defects of Rutherford's atomic model are as follows. According to the classical electrodynamics, when a charged particle like electron is accelerated, it will lose energy by emitting radiation. In Rutherford's nuclear atom, the continuously moving electron would be continually accelerated towards the center of the orbit and consequently lose energy by emitting radiation. Its orbit becomes smaller and smaller, and finally the electron will fall into the nucleus after describing a spiral path as shown in figure. But atom never collapses in this way. Hydrogen atom gives line spectra when subjected to electric discharge under very low pressure and very high voltage. Rutherford's model of atom could not explain the origin of line spectra of atoms. On the basis of above 2 points, Rutherford's model of atom was discarded. But one of the greatest contributions of Rutherford's model of atom was the discovery of atomic nucleus, which is till today accepted without any modification. Here are some differences between Thompson's atomic model and Rutherford's atomic model. We know that Thompson's atomic model states that the electron is situated in positively charged particles that are spherical in shape. Whereas, Rutherford's atomic model states atoms consist of a positively charged nucleus with electrons revolving around it. Thompson's atomic model explains electrons are stationary, whereas Rutherford's atomic model explains electrons are in motion. I have made some differences between Boers' model of the atom and Rutherford's model of the atom. According to the Boers' model of the atom, the core nucleus, which comprises protons, contains the majority of the atomic mass, while electrons are distributed in specified energy levels or shells, and according to the Rutherford's model of the atom, the majority of the atom is empty space. A positively charged nucleus is found at the heart of the atom with negatively charged electrons revolving around the nucleus. Only specific frequency waves are emitted by electrons in Boers' model of the atom, whereas waves of all frequencies are emitted by electrons in Rutherford's model of the atom. The spectrum of electron emission is a line spectrum in Boers' model of the atom, and the spectrum of electron emission is continuous in Rutherford's model of the atom. Boers' model of the atom explains the relationship between orbital size and energy of the orbital, where the smallest orbital has the lowest energy. Whereas, Rutherford's model of the atom does not explain the relationship between orbital size and energy.